Hi everyone, this is lesson 4.5, an algorithm for curve sketching. In today's lecture, I will be going through all the procedures you need to go through in order to sketch a graph. So I'll go straight into example 1 from my learning resources. Use the algorithm for curve sketching to sketch the graph of f of x equals to negative 3x cubed minus 2x squared plus 5x. When we first look at this function, we know that it is a polynomial, therefore there are no discontinuities and no asymptotes. The domain as x belongs to all real numbers. And in the first step, we have to determine the x and y intercept. First, let's determine the x-intercept, and in order to do that, we have to make the y, which is f of x, be equal to 0. That will give us negative 3x cubed minus 2x squared plus 5x equals 0. And when we solve that, x will be equal to 0 or negative 5 over 3 or 1. Therefore, at all of these 3 points, we will have an x-intercept. Next, we need to find the y-intercept, and how we do that is we make x equal to 0. When we do that, we get y is equal to 0, therefore 0 and 0 is a y-intercept. The second step of curve sketching is determine the critical points. How we do that is we have to find the derivative of f of x and make that derivative equal to 0. And then we have to solve for x. The derivative of the original function will be equal to negative 9x squared minus 4x plus 5. When we make that equal to 0, x will be equal to 5 over 9 or negative 1. And these 2 points will be the critical points. Of course, when we need to sketch a graph, it is very hard to find where 5 over 9 is, and therefore we use division, we divide it out, and that will be the same as 0.6. The y value for x is equal to 0.6 will be 1.6. Now let's try to figure out the second derivative of f of x, and that will be equal to negative 18x minus 4. Now that we have the critical points of 5 over 9, 1, we have to 5 over 9 and negative 1, we have to figure out which one is the maximum and which one is the minimum. How we do that is we plug these two values into the second derivative function of f of x and see whether or not the second derivative of f of x will be a positive value or a negative value. If it is a positive value, then it will be a maximum. If it is a negative value, it will be a minimum. When we plug in 5 over 9, which is 0.6, into the second derivative of f of x, we get negative 14. Since it's less than 0, therefore it will be a minimum. When we plug in x is equal to negative 1, we get 14. Since it's positive, therefore it will be a maximum. Since this is a polynomial function, as I already mentioned, f of x must be decreasing when x is less than negative 1, increasing when x is in between negative 1 and 5 over 9, and decreasing when x is bigger than 5 over 9. Next, what we have to do is try to find the point of inflection. That by making the second derivative of f of x be equal to 0. And that will be negative 18x minus 4 equal to 0, or x is equal to negative 2 over 9. Of course, negative 2 over 9 is not an easy number to work with, therefore we'll also write it in terms of negative 0.2. And the corresponding y value for negative 0.2 will be negative 1.2. Now we do the same thing that we have done in previous lectures. We have to write out a table of values. When we have the interval x is less than negative 2 over 9, the double derivative of f of x will be bigger than 0. Since it is bigger than 0, we have a concave up. When x is bigger than negative 2.9, we have a negative value for the double derivative of f of x. Therefore, it concaves down. And when x is equal to negative 2.9 exactly, we get 0 for the double derivative of f of x. Therefore, this will be a point of inflection. Oops. And there we have the graph. Is that At about negative 0.2 for x, we have the inflection point. At about 0.6, we have the maximum, and at negative 1, we have the minimum point. Okay, so that's the end of this lecture. Thank you guys for watching.